So 4.4, number 25, we have a rectangle constructed inside of a semicircle, and they tell us a couple things. The base is on the diameter. So this base is on the diameter. The radius of the semicircle is 5. So we need to note that the radius is 5. The other two vertices are on the semicircle, which we can see there. They want the maximum area for that rectangle. So we need an area formula. So how are we going to do this? I need a center. So here's what I'm going to do. I have to create a coordinate grid. And how do you choose a coordinate grid? Well, choose it wisely. I claim that's my x-axis, and that's my y-axis. Now, do I know this point? I don't, right? I wish I did. Somewhere along the circle, if I place that point, I'm going to have the rectangle with the biggest area. So I'm going to call that point, which I don't know, x, y. So this point here would be x. That point here would be opposite of x. And this point here would be y. Are we all good? Okay, so what is the area of that rectangle? Area of a rectangle is base times height. Well, my first question, how long is it from here to here? That's 2x. The base of this rectangle is 2x. What's the height of this rectangle? Well, the height from, oops, I don't want that one. The height from here to here is y. That is y, because y is the height here. Well, now lies my problem. I want to find the maximum of this, so I need the derivative, but I have two variables. I need a relationship between x and y. How do I do that? Here is where experience comes into play. I'm going to draw this triangle here. What do we know about that triangle? I know the radius is 5 because they told us. I know this is x and that's y because that's xy, so it's over x up y. Now, hopefully you see the relationship between x and y. I have a right triangle. I can use Pythagorean theorem. X squared plus y squared is 5 squared. Pythagorean theorem. X squared plus y squared is 5 squared, right? So I'm going to solve for y. Y squared is 25 minus x squared. So I squared that to get 25. I subtracted that to get minus x squared. Then y is going to be the square root of 25 minus x squared. A little side note for you, it should be plus or minus, but y is positive, so we ignore the negative. So what do? I place this in for y. So now I have this formula. Now I need to find the critical points, and that will tell me the possible max or min. Now, this is where it gets ugly because it's a product rule. I am multiplying that times that. So when I take the derivative, I need the product rule. So let me do the derivative of a to find the critical points. So we leave the first alone. We take the derivative of the second. And this is box to the 1/2 power, so it's chain rule. Bring the 1/2 in front, we leave box, we decrease the exponent by 1, and we multiply by the derivative of box. Uh-oh, I'm running out of room. Ruh-roh. Plus, we take the derivative of the first one, and we leave the second one alone. Wow. Ready for this? 2 and 2 cancel. What do I have left? I have an x and a minus 2x, so that's going to be minus 2x squared. This negative is going to move this to the bottom over the square root of 25 minus x squared plus 2 square root of 25 minus x squared. Okay, so I just did half power, that's square root, negative moves to the bottom. Now I want to combine these fractions, so I need a common denominator, so I'm going to multiply by 1. Which one should I pick? I pick that one. Now I have a common denominator. Everything is over square root of, that's a 25. What is that? That's craziness. That's a 25. Common denominator of 25 minus x squared. That is so bad. Minus x squared. So that's my common denominator. So on top, I'm going to have that plus that. So on top, I'm going to have a negative 2x squared plus 2. But 2 of the same square roots, the square roots disappear. So I'm going to have 25 minus x squared. Let's keep simplifying. Negative 2x squared distribute plus 50 minus 2x squared over all of this. Wow, let's just keep going. So the derivative is 50 minus 4x squared over the square root of 25 minus x squared. That is crazy. That's a lot of work. What are critical points? Critical points are the points where the derivative is 0. That occurs when the numerator equals 0. Let me add 4x squared to both sides. Let me divide both sides by 4. Let me square root both sides. I mean, not square root. Let me divide by 2. Let me square root both sides. But we're talking about lengths, so we're not going to have negatives. So I can ignore the negative. And the square root of 25 is 5. So 5 over radical 2 is my critical point. Now, I can set my denominator equal to 0 also. So when is a prime undefined? When the denominator equals 0, I square both sides. I add x squared to both sides. I square root both sides. Now, here's my question. Do we have 3 critical points? 1, 2, 3. What is x? X is this point. But what's the biggest x could be? That's the biggest x could be, which is 5, because the radius is 5. The smallest x could be is 0, so it's between 0 and 5. X could be here, or x could be here. 0 or 5. So the domain of x is 0 to 5. So these are endpoints. It actually could be to negative 5 too, I'm sorry. So we ignore the endpoint. These are not critical points, those are endpoints. Endpoints cannot be critical points. So here's the good news, we only have 1 critical point. And we learned if that critical point's a relative max or min, then it's an absolute max or min. So we make a table, 5 over radical 2, and let me get the value of that on my calculator. 5 divided by square root of 2, it's about 3.5. So it's between 0 and 5. I'm going to pick 1 and 4. I like those. Let's plug in 1 to our derivative. 4 times 1 is 4. 50 minus 4 is positive. And the bottom is positive also. So we get positive here. Let's plug in 4. 4 times 4 is 16. 16 times 4 is 64. 50 minus 64 is negative. 25 minus 4 squared is positive. So we're going to get negative here. So here is the final which you have to write out. There is a relative maximum at 5 over radical 2 because the derivative changes from positive to negative at that point. And therefore, since there's only one relative extrema, it's also an absolute extrema. So that is the absolute maximum occurs at x equals 5 over radical 2.